In this recording, I will talk about few techniques to reduce hallucination, and then we'll deep dive into one of them. So these are the techniques that I'm going to talk about, and then we will focus on the chain of verification technique. So first technique is through moderation, and how it reduces hallucination is like through retrieval augmented generation. We usually ground the language models to the organization knowledge, the knowledge base. But when you do the retrieval, if there is no context or no matching documents returned from the knowledge base, we have a blank context. And if we add that blank context to the prompt and try to get a response, the language model usually hallucinates and then still gives an answer, although it does not have any matching documents or a matching context. So in this case, the way to reduce or way to stop the hallucination is to create a relevance moderator, which will check if there is a context that has been returned through the information retrieval process. If there is no matching documents returned, then don't even send it to the language model. Chain of verification, and this is where we'll take a deep dive, is based on this paper. And I'll put a link to this paper in this recording. Now in this, the language model first drafts an initial response. Once that response is drafted, the language model is used to create some verification question to fact check the draft. And then the third step is where the verification questions are answered independently so that they are not biased by the initial draft response. And finally, the final verified response is created based on the answers provided after answers from the verified answers, right? So this is called chain of verification, and we'll see an implementation of this through a code that I have written. Chain polling is another technique. It's similar to the concept of quorum in a cluster management type of solution. If you're familiar with the Zookeeper cluster or Kafka cluster, right? So they're for high availability, right? For redundancy, we usually have a quorum, right? And the quorum is where there is more than one participant, and each participant has a vote, right? And a decision is taken based on 2/3 majority. The chain polling works similarly, where once a response is generated, the response is sent to multiple LLMs, which are participants in a quorum, let's say, to decide if a hallucination happened or not. Based on the majority decision, it is decided whether it is an hallucination or not. The last but not the least, human in the loop, HITL. This is the most reliable way to stop hallucination so far. Once the response is generated, it is sent to human reviewers to check if there is any hallucination. I intend to take a deep dive on each of them separately, but today we are going to talk about chain of verification. Now, just a quick refresher, chain of verification has these 4 steps. Drafts initial response, plans verification question to fact check the draft response, answer the verification questions independently, and then finally a verified response is generated. Now, the step 2 and 3, right? The execution of step 2 and 3, there are multiple approaches to that, right? The first approach is called joint, where the planning and the execution step, the number 2 and 3, are done by a single LLM prompt. The problem with this approach, or the disadvantage of this approach, is that since the same prompt is generating the verification question and the answer, and it takes the original response and the context also, there is a chance that similar to, like, if the original response was hallucinated, these answers may also be an hallucinated answer. Right? The two-step process is where the planning and the execution steps are separated with two different language model prompts. The planning questions are generated based on the original response, but then the planning questions are answered by a completely different LLM prompt, where only the context is taken to answer the verification questions, not the original response. So the chance of hallucination or chance of repeating the hallucination is drastically reduced. The factored approach is even better. In this approach, the generated verification questions are like if there are, let's say, from the original question, if there are 3 or 4 or more than one verification questions, each questions are answered by a separate LLM or a separate LLM prompt. Although it's relatively expensive, this further enhances the accuracy of the answers of the verification questions. And this is the approach that we'll see in the code example that I'll show you today. The last one is factor and revise, which is an extension of the factored approach, where after factoring, the response, the verification question response are cross-checked with the original response by another LLM to detect if there are any inconsistency. Right. So now let's see how we implement this. We'll implement the factored approach, and we'll implement all of these things, 1, 2, 3, and 4. Right. Let me go to the code now. Okay. So here I'm passing the context that Rahul Gandhi is the Prime Minister of India. I know this is not correct. Narendra Modi is the Prime Minister of India, but I deliberately gave this context and then asked the LLM to answer the question based on this context, because text Da Vinci, you'll see the text Da Vinci model is not able to ground it to this context. It will still answer based on its internet knowledge, where it has been where the actual answer is that Narendra Modi is the Prime Minister of India, right? But then although I'm giving it a context, it is not grounding it to the context, hence it is hallucinating, and we'll see how through the factored approach, the hallucination is removed at the end, right? So again, this is the context. Based on this context, I want the language model to answer this question: who is the Prime Minister of India? So the first part is to draft the initial response. The prompt for the initial response is: you are a helpful chat assistant. You will be given a context and a question. Please answer in details based on the context only. If the answer is not there in the context, please do not answer. And then here goes the context, and here goes the question, and finally we get the answer. We'll see that the text Da Vinci is not able to ground itself to the context. It will still answer that Narendra Modi is the Prime Minister of India, which is correct, but that is not what the context I have given. That is the internet answer, right? So this is the base response. We will print the base response to see what text Da Vinci is responding. The next step is to create the verification questions. So here the prompt is given the below question and answer. Please generate a list of verification questions that can test the accuracy of the original baseline response. And I've given a one-shot example that the original response, if the Indian struggle for freedom started in 1847 with the onset of Sepoy Mutiny, the verification question will be: when did the Indian struggle for freedom start, right? And here goes my context question, here goes the context, and here goes the base response. Based on that, it needs to create the verification questions. That is the second step. The third step is to execute the or get answers for each of the verification questions, right? So here I'm using a pydantic output parser to create the verification questions, right? So once the verification questions are created, right? So here I create the verification questions, which is a second step. So this is the list of the verification questions. Now I go to the third step, where this list, for each question in the list, I am getting the answers separately, answer the questions separately for each question, and then I am concatenating the question and the answer, right? That is the third step. And the final step is where I am now generating the verified response. I'm saying, given the original question, context, and the original response, revise the original response if applicable, such that it is consistent with information in verified source. Verified source is nothing but the verified results, like for the answers of the verified verification questions, right? And here I plug in the question, the context, the base response, and the question and answers from the verified question, right? And here comes the final response. Now I run the final response chain with the original question, the base response, the context, and the verify result string, right? And I generate the final verified response. I already ran it. So if you see what it has done is, drafts an initial response. Although I gave it a context saying Rahul Gandhi is the Prime Minister of India, TextDaVinci did not adhere to the context and still gave me the answer from the internet, which is the Prime Minister of India is Narendra Modi. The verification step created two questions. Who is the Prime Minister of India? It again, like it repeated, who is the Prime Minister of India? And for then the next LLM answer the questions independently, right? Now, since I'm using for the verification step, right, for this question, I'm using GPT 3.5 instruct, right? That is a chat model. So I'm saying, who is the Prime Minister of India, right? And based on the context, I wanted it to answer. So it says Rahul Gandhi is the Prime Minister of India. For the second question also, it answers Rahul Gandhi. And finally, generated the final verified response, which is the Prime Minister of India is Rahul Gandhi. Now it is grounded to the context that I have given, although the context is wrong again. Although the context is wrong because in actuality, Narendra Modi is right now the Prime Minister of India. But to show this example, show an example of chain of verification, I gave it a wrong context to see if actually it grounds itself to this context. So that's all I wanted to show as part of this recording. In future, I will show a few more techniques to reduce hallucination.